these questions. Make sure that you can see. All right. So in question, and I also put some work, so it's good if you didn't know how to do it or if you're not sure that you write down like how to do it. So in number 1, it says a high school science teacher has 78 students. Of those students, 35 are in the band, 32 are on a sports team, and there's 16 that are not on either. So we know 35 plus 32 plus 16 is 83. Now, that would mean if 35 were in band, 32 were in sports, and 16 were in neither, they would add up to 83, but there's only 78 students. So that means some of them must be in both. And the way you figure out how many must be in both is you figure out how big is the difference from the 83 and the 78, and that's 5. So they're not mutually exclusive because there will have to be 5 students that are in both, because when you added them all together, it was over that 78. So there had to be 5 students in both of this. So that's number 1. Number 2, it says the table shows data collected from a game. You really don't have to look at this, really, the table, but it says which of the following is mutually exclusive events. It means a person can't do both. Okay, a person can either purchase food or not purchase food, and a person can either cheer for the home team or the away team. Okay, so very simply, the person cannot root for the home team and the away team. They can't say, I want the home team to win and I want the away team to win. They have to pick one. Now, look at the other ones. They can root for the home team and purchase food. Absolutely. They can root for the away team and purchase food, of course. They can root for the home team and not purchase food. And they cannot root for the home team and not purchase food. All those are easy. Those are things that they could easily do. Number 3, expected value, remember, is where you multiply the top times the probability and you add. It's the sum of the numbers times their probability. So that's what I did there. 0 times 0.35 plus 1 times 0.20 plus 2 times 0.15. Remember when you put it in the calculator, you could put all the top ones in list 1 and all the probabilities in list 2, and then you did the stat calc number 1, and you could do the frequency list as list 2. That's another way of being able to do this. But all you're doing is multiplying the number times the probability and then adding that all up. When I added that all up, I was doing it by hand. I didn't have my calculator with me. But I just started adding the numbers, and then I added more numbers, and I got 1.79. So I just added all those together at the end. Okay, so each number times the probability, add them together. Notice what they asked for. They asked for the expected value. That's the same thing as the mean. So the word expected value there and the word mean are the same. The average, the mean, the expected value. Okay, and that is 1.79. People that knew nothing about this, any idea what you think they chose?
28.
You could add them all up and get 28. That's one way. The most common missed answer was 3.5 because they looked from 0 to 7 and 3.5 is right in the middle, the average, right? So that was the most commonly answer that was wrong. The answer 0 is there because 0 has the highest probability. The answer 1 is there because if you added all the probabilities up, they would add up to 1. So it's 1.79. That's the expected value there between those. Okay, number 4, at a sporting event, cheerleaders throw 50 bundled T-shirts into the crowd. They have small, medium, large, extra large. Suppose Anna catches a T-shirt. What's the probability she'll catch one that's not a small? Well, look, there were 10 smalls out of 50. So how many are not small? 40. Yeah, so it's 40 out of 50, and I've got to figure out where that's at. And I've lost my page. It must be over. There it is. Yeah. So 40 out of 50, which is 0.80. That's how many did not. That's the chance of not getting a small. Okay. All right, number 5. Middle school chess club has 5 members. Adam, Bradley, Carol, Dave, Ella. A, B, C, D, E. 2 students from the club will be selected at random to participate in the county chess tournament. What's the probability that Adam and Ella will be selected? So, what's the chance that you select Adam?
1/5.
1/5. And then what's the chance that you select Ella?
1/4.
1/4. Okay? That is, if you multiply those two together,
You get 1/20.
that's 1/20th. Now, what's the chance that you select Ella first? 1/5. And then you select Adam?
1/4.
1/4. And you multiply those together. That's 1/20th. So there's 2 ways, right? So it should be 1/10 when you add them together, 2 different ways. I think the wrong one is circled on here. Should be 1/10. So you should get 1/5 times 1/4. That's how. So if you select Adam, then Ella, there's a 1/20th chance. But you could also select Ella, then Adam. That's also a 1/20th chance. It says, what's the probability that Adam and Ella will be selected? It doesn't say what's the probability that Adam will be selected first and then Ella second. It just means that they'll be selected. Okay? Because it really doesn't matter who's selected first. They're being selected to participate in a county chess tournament. So you have to do, so it's B, 1/10. You have to do Adam and Ella, and then you have to do Ella and Adam. Okay? 6, 1 student from a high school will be selected at random. It says, let A be the event that the selected student is a student athlete. Let B be the event that the selected student drives to school. If the probability of A and B is 0.08 and the probability of B given A is 0.25, what is the probability that they'll be a student athlete? Now, this formula is given to you on the exam. It's the conditional probability formula. It says the probability of B given A equals the probability of A and B over the probability of A. Like the one you're given is always the one on the bottom. So the information that we have is that the probability of B given A is 0.25, so I plug that into the formula. And we know the probability of A and B is 0.08. So we just need to solve for the probability of A. So to do that, you're just switching it basically with this. That's how you're able to solve that. So the probability of A is 0.08 over 0.25. And then you just do the math there. So there's a formula, and that one's given to you also on the exam. That would be given to you on the test. You would have the formula there. You just have to plug the numbers in. Okay? So 0.08 over 0.25 is 0.32. Moving on, number 7. Okay? Those are mutually exclusive events because 28 people chose the first discount and 22 people chose the second discount. Like you were asked when you came into the store at the mall to choose one of the 2 discounts. So you can't choose both. 28 people said, I'll choose that first discount. 22 people said, I'll choose that second discount. There were 50 customers. They either chose one or the other. So the probability of them both happening was 0. You can't choose both discounts. So that makes it mutually exclusive. All right, so we move down to number 8. Number 8 says there's a simulation, and it asks, based on this simulation right here, what's the probability that at most, that means 2 is the highest, that at most 2 of the next 10 callers will have to wait more than 8 minutes to have their calls answered. So these are how long they have to wait to have their calls answered. So the probability that at most 2, that would be 2 or less, you can just add up these 3 probabilities. 0.284 plus 0.345 plus 0.181. If you add those 3 up, then you end up with 0.810, which is E. So I'm just adding up the probabilities. Because it says at most 2. Got to use the vocabulary there. All right, number 9. In number 9, it says That one was a little difficult, but it's actually an easy problem, but it's difficult. At a certain bakery, the price of each donut is $1.50. It says the expected value and the variance are 2.6 donuts and 3.6 squared. So the variance is 3.6 squared. Variance is the standard deviation squared. Okay, so the variance is 3.6 squared. Let the random variable represent the price of the donuts that a typical customer purchases each day. What is the standard deviation of this? Well, it should be the price of the donut times that standard deviation. Well, if the variance is 3.6, okay, if the variance is 3.6, the standard deviation is the square root of that. So it's the price of the donut times that standard deviation. So it's the square root of 3.6. That's a rare problem that you'll see, but it was one that they put on there. A lot of times in the AP questions, there's 40 on the actual exam at the end, but there are typically around 10 maybe that are like level 5 questions that are extreme. That would be one of those that would be above. Doesn't mean you can't get it. It just means it's not expected. Like 20 out of 40 gets you the 3 on the exam. So that's kind of how that works when you go through it. Number 10. The quality control manager at a factory records the number of equipment breakdowns each day. Let Y represent the number of breakdowns. Basically, they want to know, do you know how to interpret what standard deviation is? So standard deviation is 0.28. The definition of standard deviation is how far from the mean something is on average. So on average, the number of breakdowns per day varies from the mean by about 0.28. That's what standard deviation is. How far on average does something vary from the mean? Okay? Everybody learn a little something there? At least one or two that you didn't. Pretty difficult again. Number 11, it says, what is the best definition of the chance of rolling a number on a die less than 3? So think about it. You have on a die, you have 1, 2, 3, 4, 5, 6, right? So rolling a number less than 3 would be rolling a 1 or a 2. So that should be 2 out of 6, which is 1/3. So probability is what happens over the long run. Over a long period of time, that's the probability. So for many rolls of the die, the long run relative frequency, that means the long run probability of rolling a number less than a 3 is 1/3. So 1 out of 3. All right, we move on. Number 12. In number 12, they are not uniform, because if they were uniform, all their probabilities would need to be equal. Uniform means, like, think about wearing a uniform. Everybody's got the same thing. So they're not uniform, so I gave the definition of uniform. Uniform means the same for all. So they're not uniform. So her claim is not supported there, that they're uniform. Now, if you look at the probabilities and you are adding them up, 0.5 would occur in the middle there, where a field goal percentage of 0.4. So the median field goal percentage is 0.4. Doesn't matter if you start at the top or the bottom. If you start adding them up, you don't get to 0.5 until you're in that field goal percentage of 0.4. So that is the median field goal percentage. Now, think about these probabilities. If you made the bars on the probability, it would be a 0.1 bar, then a big 0.45, then a 0.3, then a 0.1, then a 0.05. So there will be a tail to the right, which would mean it would be skewed to the right. So if we look up there, it is not uniform. The distribution is skewed to the right, and the median is at 0.4. That's where the middle number is. All right? Now, in this one, it says he knows the probability of making a basket is 0.8 or 80%. So the best way to simulate this would to be let the digit 0 to 7 be him making a basket, because there's 8 out of 10 of those in one-digit numbers. So that would be 80% chance he makes a basket. And let the digits 8 and 9 represent him not making a basket, because there's 2 out of 10 of those, which would be 20% chance of him not making a basket. So I think that one was pretty easy as far as that goes. That was just setting up the simulation. You didn't have to run it. You didn't have to do anything except just set it up. Okay? So there are some easy ones tucked away in there. 14 is easy if you go through the process. It says, one senior from the high schools will be selected at random. What is the probability that the senior selected will not be from high school B? So you see how I marked out high school B there. I crossed it out because we're looking at what's the probability that they're not from high school B, given that they responded with a choice other than college. So I also marked out the college column, because we're not talking about people that responded college. We want people that responded everything else. So my total at the bottom is going to be the people that responded work, military, and undecided. So that's 244 plus 106 plus 188. And I'm looking at how many of them are not from high school B. That means they're from A or C. So I'm adding up all the A and C's. 99, 83, 49, 31, 63, 71. That's 396 out of 538, and that is E. Okay? And on that one, if you knew they weren't from college, if you knew you weren't dealing with college, you knew 538 was your denominator. That's the only one that had 538 as the denominator. There's no other option. All right, so we go to 15. Data was collected on the days per week that they visit a fitness center. The mean is 3.12. Which of the following statements is the best interpretation of the mean? Remember, the mean is the average. And here we're talking about the number of days per week that they visit a fitness center. So the long run average, that's what the mean is. In the long run, over a long period of time, excuse me, with repeated sampling, it should be about 3.12 days per week. And you know why the mean is 3.12? It always says the definition of the mean of a probability is over the long run. So over a long period of time, this should happen. Okay, 16, very tricky. 16 is the hardest one on here. All right, so I'm going to explain to you how I got that answer. Hold on. That's why I said it's the hardest one on here. I'm going to explain to you how I got the answer. So, the probability of A is the probability of A and B happening plus the probability of A happening and B not happening. So think, here's all the way, there's two things, there's A and B. If I want to find the chance that A happens, it will happen when B happens, and it will happen when B doesn't happen. So it either happens by itself, that's what the complement means, when B does not happen. It either happens by itself, or it happens along with B. So if I want to find the probability of an event happening, it either happens by itself, or it happens with something else. So that would be, we know that A happens by itself 10% of the time, and A happens with B 10% of the time. So A actually happens 20% of the time. Okay, for B, we know that B and A happen together 10% of the time, and we know that B happens without A 40% of the time. So the chance of B happening at all is 50%. Again, this is a harder one, but it is, you can comprehend it if you get those symbols. Now, so the probability of A happening is 20%. Probability of B happening is 50%. For the two events to be independent, the probability of them both happening has to be A times B. Well, the probability of A times B is 0.2 times 0.5, which is 0.1. And we know from C that the probability of A and B happening is 0.1. So it is independent.
But E says that too.
Okay, so let me look at it and tell you the difference. So E says the probability of A and B not happening is 0.5. So in E, I would get the probability of A is 0.6, okay, in E. And I would get the probability of B is 0.5, And when I multiply those together, 0.6 times 0.5 would be 0.3. That's the problem with E. All right. So I'm moving forward. 17. Now notice, look at these probabilities. They're cumulative. If you notice that, it says less than or equal to. It means they're adding up as you go through until you get to 100%. So you start at 0, 20%, 20%, 20%, 20%, 20%. So are these uniform?
Yes.
Yeah, absolutely. Because they're going up by 20% each time. There are no 5s. So really the 5s could be marked out, right? Because there's 0. There's 20% 6s, 20% 7s, 20% 8s, 20% 9s, 20% 10s. So 6, 7, 8, 9, 10. What's the median of 6, 7, 8, 9, 10? 8. So the distribution is uniform with the mean and median equal to 8 interviews. Okay, so it goes up by the same amount each time, 0.2. All right, 18. This is the easiest one, which is the best interpretation of 0.68. For all customers who purchase a lawnmower, 68% will also purchase an extended warranty. That's what the problem said. The problem said down here, a store owner reports the probability that a customer who purchases a lawnmower will also purchase an extended warranty is 0.68. The best interpretation of that is for all customers who purchase a lawnmower, 68% will also purchase an extended warranty. That's what we think. All right. Number 19. This is not hard either if we think through it. A company is considering purchasing the mineral rights to 2 different mountains. The probability that it will purchase the mineral rights to the first mountain is 0.55. So I'm writing that down. Number 1, 0.55. The probability it will purchase the mineral rights to the second mountain is 0.4. Assuming the decisions are independent, that means one doesn't affect the other. What's the probability it will purchase the mineral rights to exactly one of the 2? So there's 2 ways that can happen, right? You can either purchase the mineral rights to number 1 or the mineral rights to number 2. So let's do the first way. So the chance it purchases the mineral rights to the first mountain is 0.55. And if it doesn't purchase the mineral rights to the second mountain, that's 0.6. Right? It's the complement of that. So 0.55 times 0.6 is 0.33. That's the chance of it purchasing the mineral rights to the first one, but not the second one. And then we got to do the other way. The chance that it purchases the mineral rights to the second one is 0.4, but not the first one. That would be 0.45, the complement of that. So not the first one, but it does purchase the second one. That is 0.18. So I've got to add together the 2 probabilities to get my chance. So that's the chance of purchasing the mineral rights to the first one and not the second one. That's the chance of purchasing the mineral rights to the second one and not the first one. The question says, what's the probability of purchasing the mineral rights to exactly one of the 2? Well, there's 2 ways that can happen. So I've got to add them together. And so I get there's a 51% chance that I purchase the mineral rights to one of the 2. Okay. Number 20, the last one. Cut the histogram straight down the middle. It is a symmetric distribution. It's perfectly symmetric. Look on both sides, you see the exact same thing. So 300 is right there in the middle. So that should mean on a given day, it is equally likely for the museum to have less than 300 visitors as it is to have more than 300 visitors. So they have the same chance of having less than 300 visitors as they do of having more than 300 visitors. It's equal. It's the same on both sides because it is a symmetric distribution, and that is number 20.